Alright, example 3, same instructions as example 2. Simplify each expression and use positive exponents only. Do not leave negative exponents in your final answer. Alright, so if we take a look at A here, we can see right away that we do have some negative exponents. It's up to you whether you want to go ahead and move those to the other side of the fraction now or later. Doesn't really matter. I'm going to wait, and what we're going to do is we're going to use our power of a power rule here to go ahead and get this 3 taken care of on the outside. So the 2 is 2 to the first power. Remember, put a little 1 up there whenever you see a base without an exponent. That'll help remind you that we're not multiplying the 3 by the 2. Don't ever multiply a base by an exponent. However, you should multiply this 3 by the exponent of 1. So this is 2 to the third power. Then we've got x to the sixth, and 6 times 3 would be 18. Y to the negative 2 times 3 is negative 6, and then negative 4 times 3 is negative 12. So now we've taken care of the 3 on the outside, and we just have to take care of these negative exponents. So use positive exponents only, do not leave negative exponents in your final answer. Okay, so if we write ourselves a nice fraction bar here, we can take the y to the negative 6, move it down to the denominator, and the z to the negative 12, move that down to the denominator, and of course the exponents will be then positive. In the numerator, we have the x to the 18 left and the 2 to the third. 2 to the third is just 8, and then you've got your x to the 18th power. Nothing else we can do here. One thing you should do as a last check, just to make sure you fully simplified, is take a look at all your bases. We have a base here of 8, x, y, and z. They should all be different, especially if there's multiplication involved in division. They should all be different. If there's addition or subtraction, then it's a little bit of a different story, but for these kind of problems, go ahead and take a look and make sure that your bases are all different. If some of them are the same, then go ahead and perform those operations. So this will be your final answer, fully simplified form for A. For B, we have a long fraction bar here, a nice horizontal fraction bar. We've got a numerator and a denominator to take care of. If we take a look at our order of operations, though, we really should be doing this exponent first. You cannot go ahead and take something that's outside the parentheses and move it inside. So what we should do here is we should go ahead and distribute this negative 2 all the way across. We're going to distribute it to the exponents only. Maybe distribute is a bad word to use. We're just going to use our power of a power rules. So we're going to do negative 2 times 1. That's 3 to the negative 2. The bases stay the same. 2 times negative 2 is negative 4. Again, this is in the numerator. And then negative 2 times negative 3 is 6. C to the 0. Well, 0 times negative 2 is still just 0. Write the whole bottom part down. We've got 9a to the negative 4, b squared, c to the negative 6. You can do a few things at once here, but I want to go ahead and just do one step at a time for you. 3 to the negative 2, that's going to move down to the base in the next step. So 3 to the negative 2, move it down, it's 3 squared, or 9, times 9. And one thing that you can do if you want to is you can go ahead and just cross off the ones that you've done already. So if you do that, you won't forget about some of them, and I'll try to do that here in a different marker color. So we've taken care of the 3 to the negative 2, it's down here now. The 9 is here again. If we work with this a to the negative 4 and a to the negative 4, well, anything over itself is just 1. So we can actually go ahead and cross those off right now. B to the 6th and b to the 2nd power. This is a like base, we're dividing, so we're going to take the numerator's exponent, subtract the denominator. That is b to the 4th, and that's definitely going to stay in the top of the fraction. If the exponent is larger, for like bases, if the exponent is larger in the numerator than it is in the denominator, then you're going to have some positive exponents left in the numerator. It would work the other way too. If you had, maybe if this was reversed, if you had a 6 in the bottom and a 2 in the top, this b to the 4th would just be in the bottom. Okay? So that guy's done. We can go ahead and cross those off. We have the c to the 0 power. Well, anything to the 0 power is just 1. It's done. And then over here we've got c to the negative 6. Remember that we need to take that negative exponent in base and move it to the other side of the fraction. So if we do that, we're going to have a c to the 6th power in the numerator. We can go ahead and cross that off. We need to clean up this answer here just a little bit. Yes, the negative exponents are gone, which is great, but then 9 times 9 in the bottom, that's 81. And there's your final answer. This original expression, fully simplified, is b to the 4th, c to the 6th, all over 81.